Welcome everyone to session Biz 304, Embedded Video Conferencing in Any App with Amazon Chime SDK. My name is Jenny Tiedema and I'm a Principal Product Manager at AWS. With me for our session today is Mike Antonelli, Lead Platform Management Engineer at Cerner. We are excited to be joining you today from our home offices as we participate virtually in reInvent 2020. We know that you probably joined today's session to learn more about how you can embed audio and video into your application using the Amazon Chime SDK. And we promise you won't be disappointed. But you may already be using the Amazon Chime SDK without even knowing it. Much of the same audio and video technology available in the SDK is used in the Amazon Chime Meetings app. The same app that you've used for meetings with AWS leaders and technologists throughout reInvent. And that's not all. Since the release of the Amazon Chime SDK at reInvent 2019, we've been thrilled to see all of the imaginative use cases that you, our customers, have come up with for integrating real-time audio and video into your applications. From online learning to virtual fitness classes, from remote work and online focus groups to telehealth sessions for doctors and patients, we're inspired to continue expanding the Amazon Chime SDK to satisfy the requirements of even more of your unique situations. Before we dive deeper into how the SDK works, it's worth spending just a couple of minutes on why we built the Amazon Chime SDK. The reality is audio and video technology can be pretty complex. It relies on multiple integrated standards and technologies, and as builders, you have to plan for communication that can traverse all network conditions while still offering an excellent end-user experience. You have to provide applications to your users that can be used from a laptop, a mobile device, or sometimes even a regular telephone. All of these requirements mean that there is development overhead, operational complexity, and the extensibility of your application may be limited when you are building from the ground up. Last year at reInvent, when the Amazon Chime SDK launched, it was essentially made up of three parts: the JavaScript client SDK to embed into your end-user application and provide you the foundation to build a user interface for audio, video, and screen sharing features. Second, the AWS SDK used to manage meeting resources in your AWS account. And finally, media services underlying each meeting resource that the client SDK can connect the media sessions to. So at a high level, here is how the Amazon Chime SDK works. You start by using the AWS SDK in your server-side application to create meeting resources in one of the supported AWS regions. In response, you receive a meeting resource and a set of media URLs that represent the media services used to host the meeting. Your server-side application can then authenticate and authorize each user joining the meeting session and create a corresponding attendee resource by using a unique identifier from your identity system. Each attendee of the meeting is assigned a unique join token that your server application will securely send back to the client application. The client application that embeds the client SDK will use the meeting identifier, media URLs, and join token to authenticate with the media servers and join the meeting session with audio, video, or screen sharing. The client application uses a combination of secure WebSockets and DTLS through WebRTC peer connections to send and receive media to and from other attendees using the media sessions. The Amazon Chime SDK takes the guesswork out of adding real-time communication components to your apps. You can take advantage of the Amazon Chime global network with communication services available in 18 regions without additional infrastructure investment. The Amazon Chime SDK can scale up and down with no additional work and is now available across desktop and mobile clients with the Android and iOS clients added in March 2020. But instead of me spending even more time talking about how the Amazon Chime SDK works, let's hear directly from Mike Antonelli at Cerner. and about how the Amazon Chime SDK helped them bring doctors and patients together in the midst of a global health crisis. Mike?
Thanks, Jenny. My name is Mike Antonelli, and I work at Cerner Corporation. We're a healthcare IT company that specializes in electronic medical records. There's a very good chance that we're managing part of your electronic medical record today, or that we will throughout some time in your lifetime. We create software for both you and healthcare professionals, but today I want to focus on that interaction between you and your healthcare provider. When you want to see a doctor, you most likely schedule an appointment. When that doctor wants to see you again, you schedule another appointment. You might be thinking there has to be a more convenient way than going home and coming back and meeting your healthcare provider in their place of business. So I'd like to start off by sharing a demo of what it looks like to conduct a virtual scheduled appointment.
Cerner offers a wide variety of products and services. And to show you how we've integrated the Amazon Chime SDK, I'd like to show you a scheduled video visit. On the right side of the screen, you can see Power Chart, where our physicians can see their schedule for the day and use it as a jump point to launch into patient charts. On the left-hand side of the screen, I'm going to launch our iOS application, Healthy Life. Once securely authenticated, I can view my upcoming appointments. I can see that I've got the associated 2:45 p.m. appointment, and if I wanted to, I could send an invitation to a loved one or a guardian that may participate with me in my health and wellness. For now, I'm just going to join my video visit and agree to the terms. But prior to clicking the join button, I'm going to open the patient chart to simulate what it would look like if the physician was actually browsing and looking at the background for the patient prior to them actually joining the video visit. I can see that this patient has a severe allergy to bee stings and can get a rash or maybe has a minor allergy to latex. While I'm reviewing the chart, I'm actually going to click Join Video Visit from the patient's perspective. At this point, I'm going to allow access to my camera and microphone. And I'm going to choose to join with my microphone disabled. And once I've joined the visit, I can now see my loopback view because I'm the only actual participant in the room. On the right side of the screen, you can see that the banner bar has turned green to identify that the patient has joined the visit. So I'm going to join in as well. Here I'm also prompted to select my inputs and even my video quality. I'm also going to join with my microphone disabled and go ahead and join the meeting. Because we're on different form factors, you can see that there's clipping, but each of us can actually zoom in by clicking on the video stream itself, or if something became obscured, you could zoom back out. For the purposes of this demo, I'm going to zoom in. Now I'm going to go back to Power Chart, but because I want to see Power Chart and the patient during the visit, I'm going to use picture-in-picture mode. At this point, I'm actually viewing the patient, and the patient is viewing me, and I can go back into full screen mode on their chart. Something that may be interesting in this visit, based on their allergies, is whether or not they recently had a bee sting. Or I could go review their documents and see that they've recently had a COVID-19 risk screening and see what might be going on with their health. At the conclusion of the video visit, I can now click on the video call itself, bring it back to full screen, say goodbye, and end the video visit.
Now you know what a virtual experience would look like, and you can probably draw your own conclusions about what an in-person would look like from your own personal experience. Now enter global pandemic COVID-19. All of our clients, including 250 community hospitals, are seeing that people are canceling their appointments at a higher frequency, and people are also scheduling less visits because they're being asked to stay at home. Our customers needed help fast to be able to continue to deliver care to their customers. Healthcare responded by filling virtual waiting rooms, and they did this through scheduled video visits. This is an existing product integration you saw earlier. However, it was operated within our own data center. It's very successful for several appointment types that require no physical contact. Early on in 2020, the United States also relaxed their reimbursement policies for telemedicine. For this reason, existing customers were growing their utilization 400% to 800% week over week. We also had a spike in inquiries, and we more than doubled the overall size of our customer base. While this is great news for our community hospitals, I, as a Cerner associate, am thinking, can our data center actually support this growth? And if it can, how long can we support this growth? What we were actually thinking about were server procurement schedules. How long is it going to take to actually get new hardware into our data center, rack it, stack it, and actually connect it to the network? We also were thinking about existing network circuits and the impact by being a noisy neighbor to our existing products and services in the same data center. We were running several different contingency plans to scale these products and services, but we also chose to integrate with the Amazon Chime SDK. This integration today spans iOS, Android, and web applications. The requirements for this project was that we could have no new additional user training. No customer impact could be seen, and we had to improve the overall user experience. We did get a head start. We leveraged our existing partnership with Amazon and AWS around the time of reInvent 2019. We asked, do you offer real-time communication services? And they answered very quickly, yes, we have plans to launch the Amazon Chime SDK at reInvent 2019. This was great news, but it didn't meet all of our migration requirements, and so they committed to our migration requirements. By the time we saw COVID-19 impacts, we were ready to go fast and to go now. We broke this project into 3 areas. Number 1, our native client-side code. This was software that needed to be installed by the end user, and we knew we needed to get this code out as soon as possible. Number 2 was resource provisioning. You heard earlier about the architectural changes that may need to be made in our application to provision resources using the AWS SDK. Number 3, we also had the integration and redesign of the web application and the in-call user experience. But what Go Fast actually meant to us is that everyone was going to be using WebRTC using the Amazon Chime JavaScript SDK. And this was big for us because AWS was willing to go on a journey together to certify mobile browsers for WebRTC. So at this point, we had a plan. And this plan created new traffic patterns for not only us, but our customers and end users. Specifically, all of our egress traffic would now connect to managed services that didn't live in our own data center. Our application services would communicate with the control plane, and end user devices would communicate with up to 18 different media regions. However, end users are also on hospital networks, so large ephemeral network policies weren't going to be well received by our customers and hospital administrators. AWS heard this challenge by responding and putting all of the infrastructure required for media regions within the same network range as the control plane. This simplified the overall message to our customers and actually required less configuration than the existing product did. Customer integrations include more than just the video visit workflow, though. From an auditing perspective, if there were something like a billing dispute, maybe a patient or even a provider no-showed to an appointment, you want to have the auditing capability to understand that the patient was the one that didn't join and maybe should still be charged. Or maybe it was the provider that was running late and never joined the visit, so they shouldn't be charged. We also have reporting capabilities that determine things like how long do these visits take? Is it different for a dietitian than someone in family medicine? And this is important to our customers because they want to review adoption, identify usage patterns, and optimize workflows and education. The Amazon Chime SDK emits through EventBridge. We use Lambda and Secret Manager to ingest this data into existing products and services. Jenny, I hope this was an overview of our experience and is helpful and inspires other additional customers. What additional questions do you have for me?
Mike, that's great. Could you talk to us a little bit about your transition timeline? How long did it take? What went well? Any lessons learned?
Yeah, this one was a little unbelievable when I went back and looked at the calendar. But we actually shipped our iOS and Android SDK updates in about a week. We had passive introduction of that code so that we could make those changes in our control plane when we finished the project. But it took us about 6 weeks to deliver to the first testing partner. To get that testing partner to production was about 3 months, and we migrated our entire customer base in just over 4 months.
That's just awesome. So what went well during your deployment?
I think the most satisfying thing for us is that we got to focus on the actual integrations in our products and services. And what I mean there is we spent historically a lot of time focused on the audio and video parts and actually getting the communication to be resilient to connection failure and even things like moving networks. So it was really satisfying to us to be able to focus on the product integrations that we have at Cerner and not necessarily the connectivity and quality resilience.
As a product manager, I will say that is music to my ears. So excellent to hear that. Any lessons learned, though, as you were going through the deployment?
From the perspective of a recommendation to other customers, I would say focusing on the IP range notifications for firewall and ACL specifications, specifically around the media and the control plane. Today, there is a commitment from Amazon and AWS to what that range is, but obviously it can change as you add more media regions or maybe have a distributed control plane. And so knowing about these changes before your customer tells you that the service is out and avoiding unnecessary downtime is really critical. And I would recommend using the IP range notification system.
That's great. What are some of the reasons that Cerner decided to move to the Amazon Chime SDK for your apps?
Yeah, there are a few reasons, and I think the one that stands out the most is being able to leverage a managed service that can support dynamic usage patterns. And specifically around our COVID-19 response, we were having to rapidly scale the overall infrastructure in our data center, but we had to scale it to a potential, not necessarily a usage that was current. And so if that usage pattern dipped back to where it was pre-COVID, we would have to make the decision as to whether or not we continued to operate those servers or chose to kind of give them back or hand them to a different product and service set within our data center. Another one would probably be the distributed geographic media regions. For us, running all of this infrastructure in our data center had a high cost associated with opening up to new regions. And so it really lowered our new market penetration costs. And lastly, I think your commitment to WebRTC on mobile browsers. We have a very diverse set of users, and being able to offer a virtual video experience to everyone that participates in the continuum of care is incredibly important. And that commitment to WebRTC really got us the distribution that we were really excited about.
That's awesome. Speaking as a patient, letting you focus on that experience and letting us do some of that media heavy lifting, that's exactly what we want to hear, is that you're able to focus on that end user experience, in this case for patients and doctors. So that's awesome. Is thinking about some of the upcoming announcements or recent announcements for the Amazon Chime SDK, is there anything that you're particularly excited about?
Yeah, when it comes to the integration in Cerner's products and services and the additional partnerships that the healthcare IT customers that we have are already using today, the PSTN calling management is really important to us. Specifically for a use case like interpreter services, where you may have an English-speaking and a Spanish-speaking individual in the same call, being able to dial in or dial out to an existing infrastructure that's already there to support the SLAs that you would need for an on-demand interpreter service was very exciting for us. And then not necessarily in the Amazon Chime SDK, but relative to your commitment to WebRTC, a recent announcement in WebKit and iOS 14.3 will mean that we can now use WebRTC in embedded web views, and the other browsers that live on these iOS devices can also participate in WebRTC instead of having to show an error screen and say you need to switch over to mobile Safari.
That's great. Well, now it wouldn't be a fireside chat if I didn't ask you about what you would like to see. So what feature requests do you have for the Amazon Chime SDK?
Well, I think that one is a little bit challenging for me to answer, only because you've been taking our feedback for so long that constantly coming up with new ideas is a little challenging. But I will say
wish list.
Okay, so I would say rostering is a big one for us. And so today there isn't really a link between the data plane and the control plane. And so we can use the Amazon Event Bridge events that are emitted to us to maintain a consistent who's in the call, who is not in the call. But I think having that as a first-class API within the AWS SDK so that server-side we could ask whether the attendee has actually already joined the call would be very interesting to us. And then second, the pieces exist to do this ourselves, but I think it's something maybe that customers would want across the board, would be some sort of best fit media region detection API that would maybe migrate a call to new media regions as new participants actually join the call. I think that would be pretty cool, and I could see a lot of customers seeing value in that.
That's great. That's perfect, Mike. And stay tuned, because as you noted, wishes tend to come true when when you're working with us to develop a product. So we appreciate all your support and commitment throughout this time.
Yeah, absolutely. I appreciate this time and opportunity, and I also wanted to say a big thank you to Amazon, AWS, and my colleagues at Cerner. This project took a lot of hard work to go fast and to provide for these community hospitals. And we were all going through the same things ourselves at home. And so I know it takes a lot of time and energy, and I really want to say I appreciate that from all the people that were involved. So thank you.
Great. Thanks, Mike. We've seen a real-life application with the Cerner demo, and we've talked about how the Amazon Chime SDK makes it easier for developers to add audio, video, and content sharing to their applications. Now let's talk about recent announcements for the Amazon Chime SDK. Since the original launch of the JavaScript Client SDK and Media Services, and then the addition of the iOS and Android Client SDKs last spring, we also announced the ability to build Amazon Chime SDK web applications with React User Interface Framework. You can use the Amazon Chime SDK React component library to simplify implementation of common user experiences like device selection and local video preview in your real-time voice, video, and screen sharing applications. And in November, leading up to reInvent, we launched, as Mike said, PSTN audio support to allow you to connect your end users to your application using the public telephone network. And finally, we also launched highly scalable, persistent messaging in the Amazon Chime SDK. Recently, in Media Services, we announced support for Amazon Voice Focus to improve the sound quality and reduce unwanted background noise in your applications when building with the Amazon Chime SDK. We also announced the ability to analyze and modify video from your application clients before it is encoded in a session. Client-side video inspection and manipulation give you read-write access to each video frame, so you can add features like auto-framing on the user, background blurring or replacement, or apply a watermark or embedded logo in a video feed. The Amazon Chime for JavaScript SDK now supports 48 kHz audio capture and playback. We also recently added support for playback of 25 simultaneous video tiles. Customers interested in this feature can request a limit increase. With PSTN support, the Amazon Chime SDK now connects to the global phone network so that attendees can dial into an Amazon Chime SDK meeting using a telephone. This feature also lets you programmatically place an outbound call to a phone number and connect the call to a meeting session. The last recent update that I want to spend the remainder of our time together talking about today is the support for messaging within the Amazon Chime SDK. The Amazon Chime SDK messaging provides the building blocks needed to build chat and other real-time messaging features. Available APIs include sending messages, retrieving messages, editing messages, deleting messages, setting retention policies, and on stored messages, and also streaming chat export. The APIs are combined with Amazon Chime SDK for JavaScript, so developers don't have to worry about building and scaling their own infrastructure for messaging. The messaging features can be used along with existing audio, video, and content sharing capabilities of the Amazon Chime SDK, and use cases that we discussed earlier, like online fitness classes, remote learning, and telemedicine. Messaging can also be used separately in use cases like delivery applications or broadcast, as we allow up to 100,000 members per channel. I've asked one of my colleagues to join me today for another brief demo to see the Amazon Chime SDK messaging in action. But first, let's do a quick overview of how the Amazon Chime SDK messaging works. One user on a client-side application is connected to a WebSocket provided by Amazon Chime. Their client also has access to the Amazon Chime messaging APIs available in the AWS SDK. This user is a member of a channel, along with up to 100,000 other users who are also connected to an active WebSocket on their client. When the sender sends the message, the client calls the Send Channel Message API in the AWS SDK. This message and its metadata are persisted by the Amazon Chime SDK messaging service, and then fanned out to the recipients. If the recipient does not have the channel open, they can be notified that new messages are available in that channel. If they are not connected, their client will retrieve the message from history the next time the user connects and loads messages. Developers can enable sending of attachments using Amazon S3 or their choice of file storage, and attaching a link to the file in the message metadata. Developers also have the option of turning on streaming export of chat messages through Amazon Kinesis. This export feature can be used to integrate with services like Amazon Kindle for search or services like Amazon Comprehend to detect sensitive data or profanity, which can then be redacted or archived. Amazon Chime SDK messaging is designed to be highly flexible so that you can achieve the exact experience that you need. Ryan McHarg is now going to share a demo showing a chat application that uses Amazon Chime SDK messaging and the available React components, along with Amazon Cognito for identity and Amazon S3 for file storage.
Hello, my name is Ryan McHarg, and I'm a Senior Product Manager on the Amazon Chime team. Today I'll be providing an overview of our chat demo application. This demo application covers one of the use cases for Amazon Chime SDK messaging and covers a lot of the available features of the SDK, including the use of Amazon Chime React components. This demo can be found on GitHub and can be set up in just a few steps using our AWS CloudFormation template. Here on the sign-in page, if you don't yet have a user, you can enter a username and password and choose Register. Because this demo uses Amazon Cognito, on the back end a user is created in Amazon Cognito and associated with a user record for the Amazon Chime SDK. If you have a user, enter your username and password, choose Sign In, and a Lambda function will authenticate the user against Amazon Cognito. So that's what I'll do now. Once signed in, you'll see that this user has access to one channel already, and they can also create new channels. So I'll go ahead and create a new channel called Project A, and you'll see that the user is the moderator by default, and they have the option of making the channel private or public. A private channel restricts who can add additional members to the channel. If it's restricted, only moderators can add additional members. If it's unrestricted, any member of the channel can add additional members. Public channels are accessible to any users in the app instance. Users can find the channel, they can see the messages that have been sent, and they can add themselves as a member if they want to start sending messages themselves. Once I have the channel, I can of course go ahead and start sending messages. Once a message is sent, you'll see that I have the option to edit the message. So for this one, maybe I wanted to make it a bit more enthusiastic. And then once it's edited, you can see that there's a timestamp for send a message by accident. Then I have the option to delete the message. Now this delete as a user action is not a hard delete. It just makes the message inaccessible to users. If you do need to do a hard delete on a message, those APIs are available to completely remove the message from Amazon Chime. You can also delete channels, or you can set retention policies anywhere between 1 day and 15 years. So if you set a retention policy of, say, 30 days, all messages on all channels for the entire app instance, once they hit that 30-day retention period, they'll be deleted from Amazon Chime. I'm going to go ahead and create another public channel called from marketing. And I'll create another private channel. Again, private and restricted, but this time I'm going to add another user. Okay, and I'm going to sign out as this user and sign in as the other user. Okay, so this user is now signed in, and you can see they have access to the two public channels, general and marketing, and they also have access to Project Z, because even though that was private, they were added as a member. they do not have access to project A. If you go into a public channel, you can see they can see the message, but they're not yet able to send any messages. They can, however, join the channel. Once they join, they can join in the conversation. Now, if I go over to the other user, you can see that this user did not have that channel open, and a notification appears to let them know that they have a new unread message, and they can respond. That concludes the overview of the Amazon Chime chat demo application.
Thanks for that demo, Ryan. It's great to see how quickly and easily messaging can be added to an application. With these recent launches, the Amazon Chime SDK now offers a complete set of primitives across audio, video, messaging, and PSTN for builders looking to integrate communication capabilities into their applications. Here's a list of resources for you to learn more about the Amazon Chime SDK. We hope you have the opportunity to check out some of these other sessions in the business application track as you're reviewing sessions at reInvent. Thank you again to Mike and to Nellie from Cerner for participating in our session today, and also to Ryan McHarg for helping with the messaging demo. Thanks so much for joining. Have a great day.